valve openings and closings, the valve train ensures efficient combustion and optimal engine performance. The valve train consists of various components that work together to control valve operation, like camshaft, valve, valve spring, lifters, pushrod, rocker arm, and timing mechanism. Let's take a look at these parts in details, starting with camshaft. The camshaft is a rotating shaft that contains specially shaped lobes or cams. It is driven by the engine's crankshaft through a timing belt, chain, or sets of gears. The lobes on the camshaft have profiles designed to open and close the valves with precise timing. The camshaft rotates at half the speed of the crankshaft in a 4-stroke engine, 1 revolution for every 2 crankshaft revolutions.
Do you feel a little stressed when applying for a new credit card? Not at all. I use Capital One's pre-approval tool. I wasn't asking you, I was asking them. If you need help shopping for a credit card, you should get pre-approved with Capital One's pre-approval tool. Take charge of your credit by seeing if you're pre-approved today.
Want to upgrade but still paying off your locked phone? Break free from 3-year device contracts. Switch to T-Mobile and we'll pay off your locked phone and upgrade you to a new Samsung Galaxy S23 or Z Flip 5 for free.
Valves are usually made of metal and serve as the openings for the intake and exhaust passages in the cylinder head. When the camshaft lobes actuate the valves, they open and close to allow the flow of gases in and out of the combustion chamber. Most modern engines use poppet valves. Sleeve valves, slide valves, and rotary valves have also been used at times. Poppet valves are typically opened by the camshaft lobe or rocker arm and closed by a valve spring. Valve springs are helical springs positioned around the valve stems. The valve springs ensure proper seating of the valves and prevent them from floating during high engine speeds. Lifters, also known as tappets, are components that transfer the motion from the camshaft lobes to the valves. A lifter is a cylindrical component that rides on the camshaft to actuate the intake and exhaust valves. Pushrods are long, slender rods that transmit the upward movement of the lifters to the rocker arms. They are typically used in overhead valve engines to transfer the motion from the lower camshaft position to the valves located in the cylinder head. Rocker arms are pivoting levers that transfer the motion from the pushrods to the valves. They convert the linear motion of the pushrods into the required pivoting motion to open and close the valves. The timing mechanism synchronizes the rotation of the camshaft with the rotation of the crankshaft to ensure precise valve timing. This mechanism typically utilizes timing belts, chains, or gears to connect the camshaft and the crankshaft. These components work together to ensure that the opening and closing of the valves occur at the correct moments in the engine's operation. Maintaining proper valve timing is essential for optimal engine performance and efficiency. If the timing is off, it can lead to decreased power, poor fuel efficiency, and potential engine damage. Therefore, the timing mechanism plays a crucial role in the overall functioning of the engine. The operation of the valve train is coordinated with the piston movements within the engine cylinders to achieve the desired intake, compression, power, and exhaust strokes. The camshaft profiles, valve springs, lifters, pushrods, and rocker arms work in harmony to open and close the valves at the correct time, allowing for efficient combustion and power generation. Types of valve train. Different engines may utilize variations in valve train designs, such as overhead valve, overhead camshaft, or dual overhead camshaft configurations. Advanced technologies like variable valve timing and variable valve lift allow for even greater control over valve operation, optimizing engine performance across various operating conditions. An overhead valve engine, also known as a pushrod engine or an I-head engine, is a type of internal combustion engine design commonly used in a wide range of vehicles. This configuration allows for a more compact cylinder head design compared to engines with valves located directly in the head. Overhead valve engines offer several advantages. The use of pushrods and rocker arms allows for a more compact cylinder head design, making the engine lighter and more compact overall. Overhead valve engines are generally less expensive to produce compared to overhead camshaft engines, as they have a simpler valve train system. Overhead valve engines are known for their high torque output, particularly at lower RPMs. This makes them well suited for applications that require low-end power, such as towing and off-roading.
I've worked at some of the largest retailers on the planet. You think they all have it figured out, but Shopify really does.
You can build a totally custom application, and by doing that, year over year, we've been able to dramatically increase conversion rate. And that's game-changing for average order value and ultimately how much we make per visit to our website.
My father founded St. Jude Children's Research Hospital because he believed no child should die in the dawn of life. In 1984, a patient named Stacy arrived, and it began her family's touching story that is still going on today.
Childhood cancer. It's just hard. Stacy passed on Christmas Day of 1986. There is no pain like losing a child, but St. Jude gave us more years to love on her each day.
You can join the battle to save lives. For just $19 a month, you'll help us continue the life-saving research and treatment these kids need now and in the future.
I remember as a child walking the halls of St. Jude and watching my sister fight for her life. We never imagined that we would come back. And then my son, Charlie, was diagnosed with Ewing's sarcoma.
I'm thinking, we already had a catastrophic disease in our family. Not my grandson, too.
St. Jude has helped push the overall childhood cancer survival rate from 20% when it opened to 80% today. Join with your credit or debit card for only $19 a month, and we'll send you this St. Jude t-shirt that you can proudly wear to show your support.
For anybody that would give, the money is going towards research, and you are the reason my child is here today.
I was declared this will be 2 years cancer-free, but there's thousands and thousands of kids who need help. St. Jude, how many lives they do save? It's just so many.
Charlie's progress warms my heart, but memories of little angels like Stacy are why we need your help. Please become a St. Jude Partner in Hope right now.
However, these engines have some limitations. The pushrod and rocker arm mechanism may limit the engine's maximum RPM capability. The design of the valve train in overhead valve engines may limit the engine's breathing efficiency, which can impact its overall performance. This means that a small overhead valve engine will not be very efficient. This design is more suitable for larger V6 and V8 engines. You won't find this engine in a modern compact car. Chrysler Hemi V8, GM LSA V8 are examples of overhead valve engines. An overhead camshaft engine is a type of internal combustion engine in which the camshaft responsible for operating the engine's valves that are positioned within the cylinder head above the combustion chamber. In an overhead camshaft engine, the camshaft is driven by the crankshaft through a timing belt, timing chain, or gears. Single overhead camshaft and dual overhead camshafts are variations of overhead camshaft engines. They refer to the number of camshafts present in the engine design. In single overhead camshaft engine, there is one camshaft per bank of cylinders. This single camshaft is responsible for operating both the intake and exhaust valves in the engine. Therefore, a straight engine has a total of one camshaft, and V engine, or flat engine, has a total of two camshafts, one for each cylinder bank. These are commonly found in a variety of vehicles, and they are widely used in mainstream automotive applications and can provide a good balance between performance, efficiency, and cost-effectiveness. It is simpler and lighter version of the more complex dual overhead cam setup. The single overhead cam setup involves less moving parts, hence is easy to repair. And it is less expensive to maintain and manufacture. The benefit to the overhead cam setup is that it allows for more intake and exhaust valves, meaning fuel, air, and exhaust can move more freely through the engine, adding power. More the power, more is fuel consumption. Thus, when talking in the terms of single overhead cam versus dual overhead cam fuel efficiency, a single overhead cam is more fuel efficient. In single overhead cam setup, the camshaft is usually placed in the middle of the head, which denies the spark plug in its ideal location. This designs have less control over valve timing as compared to dual overhead cam. It is simply a single camshaft, regulating both the inlet and the outlet of gases, thus this engine will gain heat faster than dual overhead cam. In a dual overhead camshaft engine, also referred to as twin cam engines, there are two camshafts per bank of cylinders. One camshaft is dedicated to operating the intake valves, while the other camshaft is responsible for the exhaust valves. In a straight engine, there are two camshafts, one for intake and one for exhaust valve. In V engine or flat engine, where the cylinders are arranged in a V shape or horizontally opposed, you would have four camshafts. Each cylinder bank would have two camshafts, one for the intake valves and one for the exhaust valves. Advantages of dual overhead camshaft. By having four valves in a cylinder instead of two, a larger portion of the area can be used to let the air in and exhaust out.
Fairlife Chocolate Ultra Filtered Milk brightens all your holiday traditions. With 50% more protein, 50% less sugar, and a delicious taste, Fairlife makes any moment magical. Fairlife.
The engine can make more power if more air enters the